Hello everyone and welcome back. This is an extra from the original series, writing your first hello world in SystemVerilog. The objectives of this series is to provide a simple approach to learning SystemVerilog, and as such it will not be able to cover all syntax, all background and all usages, especially teach you hardware design and simple coding concepts such as if-else statements and for loop. Having said that, I would very much want these tutorials to be standalone, and I would try to cover the basic as necessary as possible. And that's why I'm making this extra, to clarify some background concepts. If you've already known the basic of Verilog, you may skip this one. Before we start, let me share my experience of when I first started on SystemVerilog. Many years ago, someone asked me this question: is SystemVerilog a hardware or a software? I was new and I linked coding to software, and I was immediately corrected that SystemVerilog is actually hardware. Well, I was wrong definitely, but in all fairness, SystemVerilog is both hardware and software, or in a better term, it can be used with synthesis tool or simulation tool, where synthesis is hardware oriented and simulation is software oriented. And now here you go, hello world in SystemVerilog. First, you need to create a module. A module is a representation of a block, traditionally a design block. Test is a name provided for the block. The bracket here can contain input and output port, but since this is a testing block, it does not contain any ports. Initial is a syntax where a code starts executing. It is like the main function in C programming. $display is a system function provided by simulation tool. It is used to print messages. And finally, hello world is the message. Before I forget, the initial block is a pure simulation code. It cannot be synthesized into a hardware design. You can use multiple initial blocks to start different executions. Every initial block runs in parallel. There is no way to tell in which order they happen. In this example, hello again may be printed first instead of hello world. As a general guideline, it is recommended to use a begin-end block to wrap around codes that belong together, even if there is only one line of code. If you have multiple lines of code, the begin-end block becomes necessary. Within the begin-end block, every line is executed sequentially. In this example, hello world is guaranteed to be printed first, followed by hello again. However, please note that they both happen at time 0. You can introduce delay by using hashtag followed by a time notation. In this example, hello world is printed at time 0, and then hello again is printed 1 nanosecond later. Initial block should be a syntax that is easy to understand because it is quite comparable to software programming. In Verilog, there is another syntax to kickstart an execution. It is called always block or sequential statement. Always block will execute repeatedly, and it requires a trigger event. In this example, the trigger event is 1 nanosecond, which means the block will print hello world every 1 nanosecond. The trigger event can also depend on a signal instead of time. The example here shows that the always block that uses a clock signal. It will print hello world every time the clock toggles from 0 to 1 or from 1 to 0. You can limit the trigger event by using the syntax posedge or negedge, which means positive edge or negative edge. A positive edge means a toggle from 0 to 1, whereas a negative edge means a toggle from 1 to 0. In this example, hello world will be printed only when the clock toggles from 0 to 1. Alright, for today, the key takeaway from this video are initial blocks and always blocks. Initial blocks start from time 0, whereas always blocks depend on a trigger to start. Initial block is a simulation construct and it is used to write tests. Always block may be synthesizable depending on its usage.